Okay, welcome to this video on completing the square, a different method to solve a quadratic equation. So nearly all the questions you get from the textbook or the teacher, you'll have a way to factorize that quadratic. But what you'll notice is there's so many combinations of numbers that will not give a product of that constant and a sum of this. In this question, yes, you can factorize, but you'll get many questions where you cannot. So we'll have to think of a way to solve quadratics in order for us to give us answers. Now, completing the square is one of those methods. It's a nice little way to show what the solutions are without factorization. Sometimes you can factorize, sometimes you cannot, but this method will show you how to do it, and you can do it all the time. Okay, so step one is to eliminate the constant term away from the x's and get it to the right hand side. So getting that negative 20 to the right hand side becomes a positive 20. Now x squared can be represented by a square that has length x by x. 8x can be represented by a square that's 8 by x, 8x. And we have that's equal to 20 on the right hand side. Now with this demonstration, I'll show you through this diagram that I can split up the 8x into 4x and 4x. Now why I do that is so I can attach the 4x to the square, and then I can arrange this particular rectangle in such a way that I'll attach it here somewhere. I'll attach it down the bottom. Now why I do that is because this special shape that's missing, like the name suggests, completing the square, is a square. Now that is always going to be a square. What are the dimensions of that square? 4 by 4. 4 units by 4 units. So if that's 4 by 4, what area do I have here? Now if you said 16, you are on the money, 16 square units. So I'm going to add, so I've just added that purple area. I've added 16. I can't just add 16 to an equation without balancing that out. So that's why I have a plus 16 on the right hand side. So I've added 16 there, which is a 4 squared, and I've added 16 on the right hand side. The big thing you need to notice is originally we had an 8x and we've added a 4 squared. So that 8 we halve. That's why I split up that rectangle in two parts. So a half. So that's why it's a 4, and I've squared it because I've got that square. Now the dimensions of this new square are x plus 4 units by x plus 4 units. That's why I'll represent that in a different way. X plus 4 multiplied by x plus 4. Now x plus 4 multiplied by x plus 4 is x plus 4 squared. So x plus 4 squared is equal to 36. Take the square root of both sides, and then you end up getting x plus 4 is equal to plus or minus. You need to have the two solutions, plus or minus 6. Get this positive 4, get it to the other side, and we have negative 4, take away 6, or negative 4 plus 6. And our two solutions are negative 10 or 2. Substitute negative 10 into your original quadratic equation, and it satisfies that, and you sub in 2 and it also works. And what you'll notice is this method has a lot of lines of working, and you're not wrong in saying that, because there's a whole page of working, whereas the factorized method is only a few lines. But like I said, you might not be able to factorize that particular quadratic and you cannot solve it. So this will provide you an alternative to solve quadratic equations. Okay, pause the video, have a go at completing the square for this equation. You don't have to draw the diagram like I did with the previous one. That was just to illustrate the property of completing the square. So I just want you to do this algebraically. Alright, step 1, get your constant term, that negative 5, to the right hand side, becomes a positive 5. Then with the previous equation it said plus 8x, halve the 8 to get 4 and square it. So in this case, this is a negative 4. But when you square a number, you always get positive. So this is always going to be a positive. Halve the 4, which is a 2, and square it. There's a 2 squared. But 2 squared is 4. So I'm not going to write 2 squared on the right hand side because I want to work it out. That is 4. 5 plus 4 is 9. So I'm going to write that as 9. The left hand side is x, whatever symbol that is. If it's a plus, that's a plus. If that's a negative, that's going to be a negative symbol. This thing that we squared always goes in here. 2, and then all in brackets, squared is equal to 9. Take the square root of both sides, and we end up getting x take away 2 is equal to plus or minus the square root of 9, which is plus or minus 3. Get the negative 2 to the other side, becomes a positive 2, and then we have 2 take away 3, or 2 plus 3. There's our two solutions, negative 1 or positive 5. Okay, this particular quadratic, I'll get you to pause the video now and take a go at solving this and see how close you get. You will have to use simplification of surds. Remembering our surds work comes in handy here, and simplify our quadratic. Alright, step 1, get the 5 to the other side, or sorry, negative 5 to the other side, which becomes a positive 5. And then this one here is an odd number, so when we halve an odd, you get a fraction. So this becomes half of 5, which is 5 on 2. Then we square it. 5 on 2 is the same as 25 over 4. So this becomes an x, there's a negative, what we squared goes in there, and that is equal to, as an improper fraction, 45 on 4. Take the square root of both sides, simplify our denominator, square root of 4 is just a 2. Get the negative 5 on 2 to the right hand side, and then we get 5 on 2 plus or minus the square root of 45 all over 2. And the square root of 45 is the same as square root of 9 multiplied by the square root of 3, which is, what did I say 3 for? Sorry about that. That should be a 5, because 9 times 5 is 45, not 9 times 3. And that is equal to 3 root 5. That's why I've got the 3 root 5 there. So I was just simplifying surds. Okay, and the last one, we've got a quadratic equation where it doesn't equal to 0. So let's just move a few things around. We would normally get our constant term to the right hand side, but now if I just leave the 15 on the right hand side, that is already on the right hand side. This is not a monic, so I'll make it a monic. So this is a 2x squared. How could I make that a 1x squared? I'm going to divide everything by 2. Dividing everything by 2, I get this expression. This is a negative half multiplied by x. So I'm going to add a half squared to both sides. So I'm going to add, sorry, not a half squared, a half, and then dividing that by 2, which is a quarter. So I'll add a quarter on both sides. So this particular thing in here will in fact be a half and then over 2 squared. That's why I've got the quarter. Adding a quarter on both sides, and then getting our expression in simplified terms, that becomes the x. There's the negative, and what we ended up putting in that brackets goes in there. Working this out, and I get 81 over 4. Square root both sides, get the negative a quarter to the right hand side, and then working that out. Two solutions, I get negative 4 1/4 or 4 3/4. Alright guys, thanks for watching that video on completing the square. I know that was a little complicated to see first up, but that's an alternative to solve quadratic equations. And the more practice you do with this, the better you'll become. And if you have any questions, don't forget to ask.